So we're doing Unit 7. It's our last unit for the year, and it's 3 phases. Phase 1 was net change. That's stuff like, rate in, rate out questions, or the ones that we did last time, which was the particle motion questions. So now we're in phase 2. There's 3 phases. Phase 2 is about area between 2 curves. Phase 3 is volume. We'll get there later, but let's move into phase 2. We're going to talk about area between 2 curves. So suppose I gave you guys a function f of x and another function g of x. Now suppose I asked you guys to find the area from f of x to the x-axis. That would be that little blue region there. So my starting point is A, my ending point is B. If I wanted to find that area, we could do basic geometry probably, but we also could do calculus and do the integral from A to B, right? Now if I wanted to do the same thing to find the area under the g function, then I would do the same thing. Right? That would give me that area. But what we're going to be doing today is we're going to be finding the area between 2 curves. So I have the g function, I've got the f function. I want to find the area just between them. So this weird looking little shape here in between them. Well, as you guys might imagine, I can find that area between them if I just subtract the red area away from the blue area, right? And so you could put these together as one integral then. Since they have the same limits, you're allowed to do this. You could just put them together as one integral. And all that matters is that you keep in mind that whichever function is on the top is your bigger function, so that comes first. So I put f of x first. And whichever one's on the bottom comes second, so g of x comes second. And that's how you can find the area between 2 curves. Just integrate top minus bottom. And that's what we'll be doing for the next 2 days, is finding the area between 2 curves. All right? And here's a summary of that information here. So it says if f of x is greater than g of x, that just means that f of x is above g of x. So that's just another fancy math way of saying top and bottom there. The one that's bigger is on top, the one that's smaller is on bottom. If f of x is bigger than g of x, then the area between the curves is given by this. You could write it as one integral, or you could do them separately. Either way is fine. Okay? So that would give us that area of that little green region over there. So let's go ahead and begin our first problem. It says, let R be the region in the first quadrant enclosed by the graphs y equals 3x and y equals x squared. Find the area of R. So I want to find this area right here. What is the area of this weird little sliver or this weird shape here? All right. Well, we're going to find that area, we need to know where to start and stop. So we're starting here on the left, and we're going to do the x values. So the x value at that point is 0. And then we stop here where they cross again. That x value is 3. And what's important is that we know we do top minus bottom, right? Top minus bottom. So we got to figure out which one is which. Now, sometimes you're going to have to figure that out. Sometimes you'll just know. And I think in this case, you guys can probably know which one is that. Is that the straight line or the curving line? That's the straight line. That's a linear function there. So that's this guy. So if you know what linear functions look like, okay, that's the linear function. And therefore, this guy here would be the curving one. And now that we know which one is which, we know which one comes first and which one comes second. So the one that's on top is the blue one, the 3x. The one that's on the bottom is the red one, the x squared. So if I wanted to find the area, we would do 3x top minus x squared bottom. Now, for today's lesson, I'm not going to work these out. I'm kind of hoping that you guys are competent with your integration and you'd be able to do that. I do want you to do it on your homework. I will ask you to do it on your quizzes. But in the interest of time, I'm not going to do that. But I trust that you guys know how to integrate that, plug it in, and subtract. Not a big deal. I just don't want to do it for the sake of time. So in class, we'll really just be setting them up. Okay, so I'm going to stop there. But yes, on your homework and on your quizzes, I do want you guys to work those out. On your quizzes, and on your homework, I'll say do it with a calculator or don't do a calculator. If you have a calculator, you can just punch in and get the answer right away. But if I don't tell you to use a calculator, I do want you guys to actually work it out and do the integration by hand. Okay, so you got to know how to do both of them. All right, so let's do another one. So it says find the area of the region bounded by the graphs of y equals x squared plus 3, y equals x equals 0, x equals 2. So once again, part of the skill here is knowing which shapes go with which equations here. So this is a quadratic. So since that's a quadratic, hopefully you guys know that's this guy here. That's the curving line right there. It's the whole thing, but I'm only going to trace out the part that is with the shaded area. The other piece, y equals x, hopefully you guys know that's just a diagonal line, so that's this guy. And then x equals 0, that's a vertical line right here. And x equals 2, that's another vertical line here. So I want to find that area. On the last problem, we found these numbers, the start and stop points, where the functions crossed. But in this case, the parabola and the straight line don't cross. So if they don't cross, they're going to do what they did here. They're going to tell you where the start and stop lines are. So basically what those x equals are, those are your start and stop lines. So we're starting at 0, we're stopping at 2. The parabola is the one that's on top, so the x squared plus 3 comes first, and then the minus x comes second. I think a good practice to get into would be to put each one in parentheses. I think it'll make some simplifying a little bit easier later on. Okay. All right. So I'm going to throw one at you guys to do here. You don't have to work it out in class for notes today just because of the sake of time. Homework, I do want you to do that, but in class, no. But go ahead and see if you guys can find this shaded area here. Read your instructions and set up an integral that would give you the area. And if you get some extra time because you're finishing fast and you want to practice your integration, I would encourage you to do that. But like I said, we're not focusing on that for now. Don't feel bad. So this is a linear function right here. This is a y equals mx plus b. So that's a straight line. So that's the red line. That's on top. So that one comes first. The curving line, that's an exponential function. It's underneath. So that one's on the bottom. All right, so there it is. And once again, you know, you could work it out by hand. Hopefully that wouldn't be too hard for you guys. Hopefully you understand the integral of 6 is 6x. The integral of x is x squared over 2. And the integral of e to the x is just e to the x. And then it's really just as simple as plugging stuff in. Now, I have an interesting little tidbit for you here. What's 5 minus 3? 2. What's 3 minus 5? They're the same thing, just opposite signs, right? So let's say you go through all this work and it turns out you realize, oh my gosh, I put them in backwards. You're going to get the right answer, just be negative. Just so you know. You should not get a negative answer the way that this is set up. Since we're doing top minus bottom, the area will always come out positive. When you do the regular area questions where we do the x-axis, that one's set up to where you're always setting the, it's automatically setting it up to where if the function's above, it comes out positive, below is negative. But with these ones, it should always come out positive. So if it doesn't, that means you've gotten these backwards. So Good news. If it's a multiple choice question, who cares? Just look for the same answer, just the positive one. If it's an FRQ, unfortunately, you do need to go back and flip them all because they would downgrade you for writing it wrong, just so you know. But if you do flip it, you'll get the same answer. It'll just be backwards, okay? It'll be negative. All right, so we looked at basically, this is the basic problem where you have a start, stop, top minus bottom integral to find the area between the curves. Now, what made these two easy is that you know the start and stop points. Sometimes you don't, like on example 2. I'm looking at this problem right now. Let's read it. It says, let S be the region in the first quadrant, bounded by the graph of cube root of x, that's the blue line, and the horizontal line, y equals 2, so that's the red line, and the y-axis, that's another line, so I'll include that. So I can tell that we're doing the integral, and we're starting at 0, but I don't know where we're stopping. It's where they cross there, but I don't know what that is yet. We'll get to that in a minute. But it is going to be top minus bottom, so which one comes first, the 2 or the cube root? The 2. So remember, set it up like this to begin with, and then fill them in. So the 2 comes first, and then the cube root. So I just need to figure out what that number is right there. How do I figure that out? Well, if it's a calculator question, we've done that before, and we're going to do it later today again anyway. But you find where they intersect by going to second calc, and then you intersect. You can find where they cross. But if it's not a calculator question, how do you do it? Let's write this down. How to find intersection point. To find where two graphs intersect, you just set them equal to each other and solve for x. So I'm going to take the cube root of x, and I'm going to take 2, the other function, and I'm going to set those equal, and I'm going to solve for x. That will tell me where those two lines cross. So you just set them equal to each other. All right, so we got to solve this. If you wanted to solve this one, you would have to raise both sides to the third power first. On this side, those would cancel, and on this side, I would get 8. So there's my intersection point. Apparently, it's 8, and that's what you would put right there. So sometimes they don't tell you the intersection points, and you have to find them on your own. You could do it that way, or you can use a calculator. Now I'm going to give you a problem. Yours is going to be a little bit harder to solve than mine, but you have the idea. Set them equal and solve. All right, so let's see how you guys do with one here. Now notice on this one, I don't tell you the start or the stop point. You got to find both. But the good news is you just solve it, and when you solve it, you should just get 2 answers as you're solving it. So go ahead and find the region bounded by these 2 graphs. I'll give you guys a little bit of time. Intersection points first. What did you do to find your intersection points? Okay. That's correct. So let's see how we get there. You set each function equal to each other. Now this is a quadratic, and when you have quadratics, you want it to equal 0. So I'm going to subtract x on both sides, which leaves me with this. And at this point, there's different routes you could go about solving this. For me, I think the easiest thing to do would be to add the x squared over here like this. And then I would take the square root on both sides. But you got to remember something when you do that strategy. You get a plus and a minus when you take a square root. So we end up with plus and minus 2, which is our 2 points where they cross. All right. So we'll be putting a -2 here and a +2 here. Diley, which one is on top? Yep. So I'm going to write this out first. So negative x squared plus x plus 4, and then x over here. Now, if we were to start solving this one out, like for your homework, I said we're not going to do that in class today, but I'll give you a few little hints and tips. We can combine this together and simplify it, distribute the x, the negative into the x there, and then these x's are going to cancel. So you really just need to solve this when you start integrating. Okay, so you would start integrating at that point. So yeah, go ahead and simplify them if you can. That'll make the integration a little bit easier. But I am going to stop there. I'm not going to go any further. So there's that. So we've looked at two types of problems. The basic idea, top minus bottom, integrate from start to end. The second thing we've looked at is you have to find your own intersection points. Now here's the next level of torture. Sometimes they won't even give you a picture. Okay? And the problem that's going to create is now not only do you not know the intersection points, but we know how to deal with that now. You can find the intersection points even if you don't see the picture. Just set the equations equal and solve, right? But the other issue that's going to create is you're not going to know which one's on the top or bottom. But I'll show you how you can figure that out, okay? So here we go. If you have a graphing calculator, then just graph your own picture. That's a nice one to do it. So you can make your own picture in that case. But they will have non-calculator questions, so you have to know how to do it without a calculator. So how do you do it? Find where they intersect first, okay? After that, we need to figure out which one's on the top and the bottom, and the way that you do that is you have two different ways of doing it, okay? This is the one I'm going to use for in class today. What you can do is, like, let's say that I find where these two functions intersect, and let's say they intersect at negative 2 and 2 again. So I know that's my start and my end point, right? Now I want to figure out which one comes first and which one comes second, and I'm not sure. Well, what we can do is we're going to have two functions. What you could do is just pick a number between negative 2 and 2, any number you want. 0 is probably a good choice. Plug it in and see which one's bigger. If f is bigger than g, then you'll do f minus g. If g is bigger than f, then you'll do g minus f. So just pick a number in between there and see which one's bigger. Now, and I would recommend this for FRQs. Okay. Now I'm going to show you the other way. It's kind of goofy, but here's the other way. Just take a guess. So in other words, I don't want to plug a number in. Maybe they gave you a really ugly function where plugging it in would be kind of tedious and you don't want to do it. Well, what you could do is just throw it in there however you want to. Because what did I tell you happens if you put them in there backwards? You get the same answer, it's just negative. I would say go for it. If it's a multiple choice question, just do it that way. If you get a negative, like, oh, I guessed wrong, but I'm just going to find the positive version of my answer. That'll work just fine. Don't do that with an FRQ, though, because if you do it with an FRQ, you have to go back and you have to erase everything and rewrite it. Major time killer. So it's worth it to take the time to see which one's bigger by doing a test point. Okay? But however you want to do it is fine. So they're not going to give us a picture. What do? Step 1, find where they intersect. Step 2, determine which one's on the top and bottom. Step 3, maybe try sketching a little picture. That might help too. Now you're not going to be able to draw the graph probably because most of us don't remember how to graph every function, especially some of the weird functions they're going to give you. It's not like, I don't know how to graph that. But what you can do is you can kind of fudge it, and I'll show you what I mean by that. Okay? You can kind of get a guess. There's some parts that you'll know for sure how to graph, other parts not so much. So here's a great example of one where you don't have a picture. So it says write but don't evaluate. That means they don't. If I ever say that to you on your homework or quiz, by the way, if I say write but don't evaluate, that means you really just need to do the integral and you're done. You don't have to work it out like we've been doing all day. So that's all we need to do here. Write but don't evaluate an integral expression to represent the area of the region bounded by this and this and this in the first quadrant. Okay? So what did I say to do first when you don't have a picture? Not yet. First. Look what we just wrote. Huh? Find where they intersect first. Okay, so let's start there. So I want to find where this one and this one intersect. Look at this one. Why am I not including that one? That's a vertical line, right? You guys recognize that's a vertical line? That's just telling you where to stop. Okay, that's not telling you the functions that are crossing. It's just telling you where to stop. So I'm not going to include that one. I'm going to set these two functions equal to each other. E to the x over 2 equals 1. Well, no. Yeah, that'll work. Let's find where they cross first. So how do I solve this? And this is where every problem will be a little different. So I'm just relying on your guys' math knowledge here. How do I solve for x? Yep, you're going to ln it. So we're going to ln both sides. These go away. Does anybody remember what ln of 1 is? Remember, this is not a calculator, so you're not supposed to be able to punch it in. It's 0. Yeah, so that's nice. 0. And then if we multiply both sides by 2, we get 0. So it seems like these two graphs are crossing at 0. They intersect at 0. So I've got these two functions, e to the x over 2 and y equals 1. We're starting at 0 because that's where they're intersecting, but we're stopping at 2 because that's where the directions tell us to stop. So they're not intersecting here necessarily. They just want us to stop there. Okay, so I found where they intersected. Now, let's go ahead and I'm gonna try to sketch a little picture here. All right. Now, some of this stuff is easy to sketch, like x equals 2. That's what x equals 2 would be, right? I'll make that red. Why not? X equals 2. By the way, I'm only in the first quadrant, right? So that means I'm going to ignore all this stuff down here. I don't care about below the x-axis. I'm only in the top right corner. So there's x equals 2. Hopefully you guys know how to graph that. That's not too bad. I think you guys probably know how to do this one too. Y equals 1, right? That's just going to be a horizontal line. That's going to look like this. So, and I'm going to stop there because that's where they intersect, right? They want me to stop at 2. So there's that. Now here's the problem. I have no idea. I guess I'll keep this stretched up. I have no idea what this looks like. Well, I actually do, but I'm going to pretend I'm like you guys. You guys know what that graph looks like? So it's hard to remember all that stuff from pre-calculus. So, but here's what I know. I know they intersect where? So I know that this line and the blue one, I know they intersect right here at 0. So I know that it starts there. So I don't know what the graph does. It either goes up like that or it goes down like that. It's one of them. If it goes up, then the e function's on top. But if it goes down, then the y equals 1 is on top. Okay? All right, so I don't know what the graph looks like, but I'm just putting on paper what I do know so that I get it a little bit. All right, so here we go. Step 1, find where they intersect. Step 2, we need to figure out which one's on top, which one's on bottom. Where are we starting at, guys? 0, where are we stopping? 2. That's where they intersect, and that's where they told me to stop. Now, how do I figure out which one's on top and bottom? Well, you have two options. You could just guess and see if you get the positive answer. If you do, then you're right. Or you can use the other strategy. I'm going to use the other strategy. I'm going to pick a number to plug into each of these problems. So you guys pick a number. What number should I pick? 1. It has to be something between 0 and 2. I've got to pick a point between there because I want to know which one's on top in between 0 and 1. So, I'm sorry, 0 and 2. So I'm going to plug in 1. Now, unfortunately, that still doesn't help me because I'm sure many of you guys are looking at this and thinking, I don't know if e to the half is bigger than 1. That's a weird thing to know. Some of you might know. That's awesome. But we could mess with this a little bit. Any ideas of how we can maybe mess with this to kind of get an idea. ln again. We could ln. Let's try that. I know that ln of 1 is 0. These cancel, and that's half. Which one's bigger, a half or 0? Half is. So which one's bigger? E to the half is bigger. Okay? So this is the bigger one. So e to the x over 2 is bigger than 1. Therefore, this is the top one, and this is the bottom one. So it's more like this picture here on the left than like the one on the bottom. So it's going to be e to the x over 2 minus 1 dx. Okay? Now I'll give you guys a little hack. Okay, let's say this is an FRQ question. You're running out of time, and you forgot how to do this, or maybe you're trying to do it and it's just not working out. You guys want a nice little trick? You're just going to take a random guess. Let's say you guessed wrong and you did this. That would be bad, right? Because they want you to set it up right. If you don't set it up, that's pretty much all the points. Awesome fix. You ready? Doesn't matter now. Absolute value makes it irrelevant. So you can kind of cheat like that. Just throw a little absolute value on there, like, I got it right. And they're like, I don't know if they know how to find the top function now, but it's okay. It's okay. You can do that. They can't ding you for it. So. All right. Here's one for you, though. Now, I do want you guys to figure out which one's on top. So, even though I'm giving you the hacks, go ahead and apply what we've learned to figure it out. But there it is. So, the place where they intersect is 0 and 3, and the function that's on top is the x minus 2x squared. All right, we're going to move into our last layer of challenge for the day. It's not hard, but it's just different. All right, so our first layer was basic. They just give you everything up front, so you just got to set it up. Second layer, you got to find your own intersection points. Third layer is they don't even give you a picture. Those are the hardest ones. So now we're going to talk about calculator ones. So let's do that. Go ahead and turn on your calculators. And I have a warning for you. If you're using my calculators in class, for the rest of the year, it's really important that you guys start by doing second plus 7, 1, 2 to reset the calculator. Because I have my pre-calculus kids using these calculators now, and they are setting it to degrees instead of radians, and they're doing other things that will cause you to get wrong answers. So every time you pick up my calculator now, make this your ritual to reset the calculator, and you'll be good. Okay? I told them to put it back before they, but they're not. And actually, some of them are actually changing the backgrounds to weird little pictures now, too, I've noticed. This will also fix that. So I would encourage you guys to always reset your calculators now. Okay? Anyway, let's begin. Let R be the region bounded by the graphs of f of x and g of x in the first and fourth quadrant. Find the area of R. So let's go ahead and graph those. I want you guys to graph this one under y1, and we'll graph this one under y2. And then let's bring up the picture and see what that looks like. So I'll give you guys a second. So right now, that's what our graph looks like. I think it's kind of easy to see what they want. They want us to find the region between those two curves, which is in the first, which means the top half, and the fourth, which is the bottom half, quadrants. So do you guys see, if I had to shade this, do you see what area I would be shading right now to find the area of? Right about there. So why there? Well, first of all, is that in the first and fourth quadrant, like it's saying? Yeah. And also, we have a start point and an end point. We're not going to go beyond that. That area is, there's no place to stop. So we'll stop where they intersect. All right. Okay. So the first thing that we want to do is we want to figure out which function is on top. Which function's on top? So go ahead and push trace on your calculators. Trace. And scroll over and see where your cursor's at. You guys see where your cursor's at? Okay, I'm looking at Brandon's right now. And as he's moving his cursor, it's like right here. So right now, his calculator is tracing the blue line. So which one is that? Well, look at the top of your screen. That's the one that it is. So Brandon, what's at the top of your screen? So the blue line is the sign. So for what I've drawn up here, you guys, if you put them in backwards, then you'll have opposite. But for the way I've drawn it here, the sine function is the one that's on top. So you guys see how the sine one's on top in my little green area here? So I know that that one has to come first. So that's how you can tell which one's on top with a calculator, is you just use the trace button to see which function is which. Okay, now we need to figure out our start points and our end points. That's here and here. For that, we're just going to do intersections. Now, you guys could probably figure out what this is. What's that? That's 0. You can just tell by looking they're crossing at 0. That's easy enough. But we need to find this other one over here. So let's find that. Now, if you guys don't remember how to find where two lines intersect, I'll remind you of that right now. You're going to push second, and then you're going to push Calc, and then you're going to scroll down to intersect, and then push enter. After that, you're going to have to move your cursor using the arrows. Move your cursor to somewhere like really close to where you want it to be. Now, if you put it there, you'll be really close, but your calculator can give you an exact answer. But to get the exact answer, you have to push enter 3 times. Enter, enter, enter. So push enter 3 times and see what you guys get. Azimuth, what'd you get for that? You got 1.464? I think that's different from what I remember. Okay. I'll look at it with you in a minute. Let me see if someone else knows. I remember being something else. Jazeer, what did you get? What is it? Oh, so it is 1.46. Is that the whole integral? Or is that just the... That's the x value. Okay. All right. I'm remembering wrong then. 1.464. So you were right, Azimuth. My bad. All right. Now, is it still on your screen, the 1.464 in the bottom there? Yeah. Keep it there. I'm going to show you guys something kind of cool. You don't have to know how to do this, but it's kind of helpful. Push enter. It shouldn't do anything. Is it still there? Okay. Now I want you guys for some reason you have to push enter first. I don't know. Sometimes it works, sometimes it doesn't. But push store. Now you should be back on the home screen, and it should say answer with an arrow next to it. You guys see that? Yeah. That means the calculator remembers what that answer was. Let's call it something. We're going to call it A. Okay, now here's how you do it. You push alpha, A, and then enter. That from now on, your calculator knows that if you type A in there, it's going to put that exact number in. Now, what's the benefit of that? You could just write this down on your paper and use that, but here's the downside. That's a rounded number, isn't it? So if you're using a rounded number, every answer you get after that will be slightly off. But if you store that number exactly as it was in your calculator, every answer will be right on. So that's one way. Also, it saves you some typing. All right, let's go back to our home screens. Let's type this in. We're going to do this. 0 to A, y1 minus y2 dx. And by the way, somebody in my 4th period showed me something kind of cool. You know how we get y1 and y2? They found a really cool way to get that. Let me have you guys bring all this up first. So let's do the integral, and I'll show you how to bring up the y1 and y2 in a shorter way. So do math 9 to bring up your integral. Put 0 on the bottom. And for the top, same thing. You're just going to push alpha A to get your A up there. And by the way, that your calculator knows what that's supposed to be now. Alpha A. Now, for the Y1, here's what they said. I think it's this. Let's push, let's figure it out. There it is. All right. So push alpha trace. Push alpha trace. Alpha trace. Do you guys see how it has Y1, Y2 in a little box there now? So you can pick them out of that box. That's a lot faster than doing the whole bars thing. So do Y1 minus Y2. Don't forget, we are doing subtraction. This is not a negative, it's a subtraction sign. So make sure you use the right one. And then get an equals on there and see what you guys get. All right, let's see. How about Vega? What did you get? 1.98 what? Okay, so there you go. So I showed you some interesting little tricks with the calculator, but here's the big idea. Graph it, find where they cross, figure out which one's on top and bottom, and that's how you can do it. We're kind of out of time. We have only 3 minutes left, but if you guys want to try one really fast, there is one here for you. I'll put the answer up in case you want to try it, but we are done for the day. If you don't want to do it because you want to pack up and get out of here, that's fine. But here is the next question, and I'll put the answer up for you in just a sec.